So yeah, as you come in, get your computer set up, get your VM going. If you ran the scripts before you left last night, just have a look at the command window. And apologize for getting really quick last night, and we're going to slow things down. It's the morning. Hopefully everybody had a coffee. And I realize that we have 3 threads going now. People maybe don't even remember the thread we started on Tuesday, but we started a method editing or a method design thread where we were building we built a spectral library that corresponded to what you did in tutorial 1 on day 1. Then we started a command line thread that we started yesterday in the SkyJam, and we kind of ended yesterday. I had some of you people who were really, really with it and awake last night started running a multi-processing command line thing that was going to go do 10 different processings on a certain template file. And then we had this thread that we were working on yesterday where we were looking at trick, and we're going to do some scoring comparison and try to understand how these scoring engines and how the Q values relate to each other and stuff like that. So I'm going to try to wrap up some threads. And the first one I'm going to try to wrap up is this command line use. I thought, luckily I caught the first bus here today, and so I created some slides to try to wrap up command line use. So, and first of all, here, hopefully everybody has this by now. You have something that has this set of Skyline files. I have a browser on multiple machines with those files listed. Just keep that browse window up. I don't know that I don't actually have anything definite on there right now that you need, but I may continue to put stuff up there. So, and then on command line use, I just wanted to remind everybody that we're using the command line in sort of a special way in this course. But there are 2 ways to use the command line, and you should just sort of ask yourself, do I know where Skyline XE is? And if you use the web install, chances are you don't know where Skyline XE is. It's like buried, it's buried in some Windows directory, very hard to find. And in that case, you should be downloading Skyline Runner or Skyline Daily Runner, and you would just download, that's on the install page. So when you go to the website, go to the website. If you go to, I want to do new one. So if you get onto any installation page, here's the Skyline Runner. So you can, when you do a web install, which is this, you're gonna get it installed somewhere hidden, and then you just get this Skyline Runner, and then that's the thing that you run. But if you do it, there's also something called an administrator install, which is how things are installed on your VM. So that means that Skyline Runner won't work. And instead, what an administrator install works more like you might expect of most programs, and you end up with a Skyline folder under program files. And then there's a Skyline XE in here. And there's Skyline XE. And there should be a Skyline CMD XE. And so you just run that. If you know where Skyline XE is, there's a Skyline CMD XE right next to it. Just run it. If you don't, use Skyline Runner. Yeah.
I have a question. So in general, something a bit more general, nothing related to Skyline Runner. So
Okay.
We're working a little bit on the width files. You commented a little bit on the top files. But I was just thinking, I'm working with Orbitrap, and I was thinking if...
You're working a little bit with Orbitrap.
I'm speaking not loud enough.
No, it's because the recording.
It's already recording.
Yeah.
Yeah, I was just thinking if there is any preferred setting in order to bring in and to upload the data into Skyline on Orbitrap data, because we always have slight preferences on the individual instrument settings and what you use, like centroided, resolution type. I mean, also depending on what kind of use, but in general, there is some things related to the instrument.
We were discussing that. Yeah, we're like, oh, wow, you know, I basically, you know, this is ETH, and they're using a lot of SciX stuff, and they sort of came up with the set of files that we're going to use for this course, and if you come to the UW, we'll be using a lot of thermo files and talking a lot about thermo. But I was just, you know, Skyline is very agnostic. I mean, you could be using, you know, any instrument from any one of the 6 instrument vendors. What we decided to, Ben and I was speaking with Ben, and we decided, one, we're going to try to give you access to some of the lectures where Jarrett Egertson in our lab actually goes over real, you know, details of how to set up a thermo instrument for DIA, and I mean, he gets into automatic gain control and stuff like that. And then, but what we're seeing happening in our lab as the preferred model right now is that people are just acquiring directly to centroided data. So we just throw away all the profile data. You know, as somebody mentioned, you know, profile data is a bit of a trick. Like you know, in a lot of cases, they're not actually storing those entire profiles. They're actually storing something like a centroid, and then they reconstruct a Gaussian around it. And if you look at thermo data, it's incredibly regular. It's really nice for tools, because tools can figure out, oh, this, you know, tools have a much easier time centroiding thermo data because it's basically constructed out of centroids. So we just throw away you know, so because the files are smaller and DIA files are so big. And then, yeah, we rarely at this point use the Orbitrap import. We use centroided import with like 10 ppm. So that's my go-to for everything, I would say, but and I've done it with Bruker as well. You want to use centroided data, and I'm just saying for the 5600, I've seen no evidence that centroiding works, and centroiding is a little bit more complicated with SciX data. So yeah, you've ended up sort of going through a more complicated route because SciX doesn't store centroided data at all. And so it can take quite a long time to convert files to centroided for SciX. So, and then and anytime you do a conversion, like Skyline generally will import directly from files. We have all these MZXML files, but Skyline doesn't need those. So generally we're importing from raw data files. In this case, SciX files are much larger than the MZXML files, so we don't have the raw WIF files here. And then also with 5600 data, I guess I've never seen an improvement, so I don't see the value of converting it to something centroided and then importing that into Skyline, because you duplicate, you know, you have all this extra time to centroid it, and then now you've got twice as much data to store. So, but for the 6600, I have seen value, and that's definitely in the Navarro paper. But for SciX, I would recommend, rather than just going to Skyline and setting centroid and importing from the WIF files, that you actually do a conversion and end up with MZML files. I wouldn't do MZXML files because they actually lose information, but that's what we're using here. So I would go to MZML files, and then I would import the MZML files. So if you feel for SciX, if you're using SciX and you feel like you need centroided data, do a conversion, because otherwise, every time you import that file, SciX is going to do an inline conversion, which can, you know, triple the amount of time it takes to import something. But whereas both Thermo and Bruker can import their centroided data faster than they can import their profile data, and with Thermo and Bruker as well, people are just throwing out the profile data. It's just too big, it's too much, you know, and we're not seeing a value to it. So people will just acquire in centroided mode. Does that answer your question?
That answers it, yeah.
Okay, good. All right, so let's go back. Okay, so here we are. So if you can find Skyline XE, use Skyline CMD XE. If you can't, use Skyline runner.exe, documentation below web install. And then the model we've been finding is design a template method. And you can do this for DIA, you can do this for anything, right? You spend some time in Skyline, and there are webinars and tutorials, and we've been going this route of, we've been taking a fairly linear route of take some DDA data, build a library, but there are lots of ways to build a Skyline method, and there's lots of documentation on it and prior tutorials. But so that all just fits into this design a method, but the method ends up being a Skyline document, right? You have all your settings in a Skyline document, whether you imported an assay library, whether you built a Skyline bibliospec library, however you built this method, that's the starting point. And then I've given you scripts. There's a multi-analysis script, so you can line up, 10, 20 things, run them overnight and go to sleep, and then, and then come in the morning and have a look at them. And then there's an individual analysis file, and you have those two scripts, and I use those all the time, and I kind of massage them and change the parameters, and you now have the power to do that too. So, and that script does this very powerful paradigm of first, it takes the template method and saves it somewhere, imports data, does a reintegrate, which creates a model, right? Creates a scoring model that you now understand. And then it exports some report. And at this point, if you want to export more reports, you can export as many reports as you want. We now have a script that exported 2, and you can add as many as you want to that. And then, yes?
Can you share with us the edited script that you had last night, that you ran last night?
Edited, oh, yeah. Well, it's so, I mean.
I know, I just missed the copy.
Oh, yeah, okay, so let's go back to that script. Okay. Let me finish up here. We're gonna get back to, so this is the last slide in this thing. So we export the report. So this is the individual, this is what happens inside of each individual run. And actually, now that I'm thinking about it, I just created this slide this morning, put a loop here so that you could do as many of these as you want. Actually, the analyze R happens in that individual thing too. So, and then finally we analyze in R, and now we can use R to create new reports. If sometimes I actually have R extract all the things and create a CSV that I can open up in Excel and do, if I want to do an Excel plot of my multi-analysis, I'll have R figure that all out for me, and then I'll just open it up in Excel. So you get you get a report out of Skyline, and the Skyline reports are incredibly flexible, I guess. Along with design the method, you might spend some time designing what is the report information you want to get out at the end too. And so I've given you some canned reports, but there's an incredibly flexible report system in Skyline that you can work on yourself. So let's go back and look at the VM now. I wanted to do the overview of what the steps are, and I'll make sure you get these slides. And so then back in the VM, so in multianalysis.bat, we started out with, I had an edited script. This was all down at the bottom. Actually, I could probably just undo and get back there. So the original script looked like this. We ran one run, and then we had a go-to end. So our multi-analysis bat was really designed just to run one thing. And then I took all of this, these other 9 runs, right? So all of these just say, hey, call the single run script, and if you get an error, just get out. I don't know. I've been thinking about removing that because it's kind of a bummer when you wake up and there was an error and then nothing else went. But sometimes the error is because you messed up the script inside. But anyway, so this stuff was down at the bottom, and all I did was copy paste to put it up. There's basically 2 regions of this file. This top region is the stuff that's going to get run, and then everything between go to end and end is just sort of storage for things that you're interested in, and I just flipped them, right? And so now I'm going to go ahead and redo. That's what so I copy pasted that, and then I took this other one and put the go to end above it. So there it was, and that's what I ran last night. Yeah.
I did it as well like this, but it didn't work. It only ran like the first. It seems like in my command line.
Okay. Well, let me take a quick look at that. So this is what this.
Yeah, I had only the first.
Yeah. So maybe you got the go to end in the wrong place or something like that. Because let's see. If exists, and you only got the first one. Well, let's look at your log. Do you have your import log?
Yes.
What happened? Page down. Yeah, I don't think you actually ran it. Okay. You got it edited, but you didn't actually do. So you'll see that I have a single run. So yeah, her import log. So if you actually ran the script last night, then what you would see, if we go to the DIA course folder, DIA course data. So every time you run this script, it will create an import log. And so if you've run the script twice, you should have the import log, which is your most recent run, as well as a time-stamped import log, which is your previous run. And so if you don't have those two files, then you didn't run it twice. And so now, if I right-click on this time-stamped one and edit in Notepad, then this was the run I did on the first day. And you can see it's a single run. That's the 10 ppm with a 10 retention time window. But the import log, which I've now been tracking, this is now a really big thing that covers 9 runs. Did anybody do that successfully? Does anybody have 2 logs? All right, awesome. So, and does anybody have their command window sort of filled with all these times? No? He gave you an error. Okay, well, I'll come look at your error, but I don't know what that would be.
I had it the same. First, it was an error, and then I did it just twice, and then it went through. So I had exactly the same issue that
okay.
the first run was not going through.
Okay, well, I'll come look at the error, because the error will be captured in the log. It will, you'll see some explanation of the error in the log when we look at it. But let's look at this first run. So we kind of blew right past this so that we could get.
Can I just have a short question?
Yeah.
Can you wrap around maybe again, like, what was the input of our scripts? What was the inputs that the multi-analysis path used? So was it the Skyline template, right, with the spectral library inside, and then with the raw data imported as well? Or
no. The input was just the template, right? So let's go back to that's kind of why I created this. So we design a template method. No data imported yet. Then we saved a copy of that, imported the data, reintegrated, exported the report, and save. And so again, if we carefully inspect the log file, we can see everything that happened, right? So here we called Skyline CMD.exe. We said, hey, we're going to start with this Skyline file, and out we're going to save to DIA course. So we're going to save to this external place. And then what we did is we changed the resolving power, or the product scan resolution, to 10 ppm. And then we set the retention time tolerance to 5 ppm plus or minus, or 5 minutes plus or minus, right? So that's setting up our template file. Let's
Sorry, and okay, I get it. But in which script, where do we specify kind of the directory of the MZ XML files that the script
So that's
uses?
that's the directory of the data files. That's one of the parameters that is provided to. So we've got something that runs a single analysis, and we've got the multi-analysis. And so here, this DIA data points to where the MZXML files are.
And do they have to be MZXML files?
No, they could be WIF files. They could be any data files.
Okay.
So if we go back to the import log, or the import this one log, then now we see the next step. So we saw this first step. This is the step that just saves it to a new location. Then we see this next step where we call Skyline CMD.exe again, and we tell it import process count, import, and then we say import all in DIA data. So that's where we're saying this is where the WIF files are. This is where the MZXML files or whatever files are. There's also this import naming pattern that allows us to extract a portion of the name of the file to have the name of the replicate in Skyline. And then now we start moving into defining we want to do we want to reintegrate with a model. So let's quickly go to the DIA data folder. And so you all should have hopefully at least one new folder under the DIA data folder. So now the DIA data folder contains all the 6 MZXML files, but it's also got a folder for every trial we did. So anybody who did the multi-run, if you successfully achieved the multi-run thing, then you should have 10 of these. And if you didn't, you should have 1. You don't even have 1? Okay, that's fine. It's fine if you only have 1. I can talk to you during the day, and we can get you set up so that hopefully, like that's why I did it yesterday. Hopefully tonight we can get you all set up, and everybody who didn't achieve this last night can achieve it tonight. So we're going to try to get everybody to have these 10 folders by tomorrow morning. Okay, so we'll look at errors, and all the errors will be captured in these logs. So let's keep just looking at this log. This has we write the entire command line that we executed up here, so you can inspect what was the command that went to Skyline to achieve what happened. But so first we open the file, save it to a new location, and that's basically, if I drill into one of these folders, here is my Sky file. So that first step, all it does is save this Sky file, right? So we get a new folder, we get a Sky file saved in it. Then this next step says, okay, let's open that file, and now we start loading data. So this is the data import. We've pointed it at the MZXML files, and we say, start loading that. And Skyline goes, yep, I saw 6 MZXML files in this data directory because I said import all from DIA data. And it says, oh, yep, there's 6 MZXML files, and you could have 100 in there. And Skyline would sort of list them all, and then it would start doing these imports. And why do we get 3 side by side? What's controlling that? What? Yeah, and what parameter told it to do it that way? Yeah, import process count 3. So we could do import process count 2. If we had a really big computer, on a 24-core computer, I'm doing import process count 12, and that makes things like 6 to 8 times as fast. So if you have something that's like a big server computer, you have to think about how many processors does your computer have. And in this case, 3 was definitely better than 2, and 2 was definitely better than 1, but I don't think going any higher would help. So we might actually even get slower if we tried to do all 6 in parallel. So Skyline processes these all individually, and then it does this joining thing where it pulls them all together into a single file, and you can look at how long it took to do each one. And then now it updates its internal statistics. It starts creating the peak model. So can people follow along in the log? Do people have the log open? And so then it calculates these scores. It trains the model. And then one really nice thing to be able to look at, after having to drill into a bunch of Skyline documents to look at this, we actually now print out the model, right? So you can look in here and go, oh yeah, you can check this visual representation of the weights and the percent contributions of the model that was trained, and you can see how it's changing when we're changing things. And then we adjust peak boundaries, save the file. You can see that saving the file takes more time than it took last time because now it's got all its results in it. So this one was relatively quick because we're just saving the template. And this one takes longer. And then finally, we just export a report. And then we start, and then we export a second report, and then we start running our statistics from the command line. So let's go see the results. Everybody's got one folder at least. So the result, so I have 10 of these now, and in each one, if you have only one, then you would be in this 1010. So ppm 10 RT 10, and does everybody who has one of these, do you have a peak areas CSV and a SWATH benchmark CSV? And you have a Sky file and a SkyD file. So the SkyD file is all your chromatograms, the Sky file is, and we'll open that Sky file and well, that might take a few seconds. So let's go ahead and start Skyline. And go open DIA course data, DIA data, and here's my TTOF64W.sky file in ppm10 RT10. So does everybody see how that sort of what we're doing our trial on is encoded into the directory name? So I have, what I'm really trying to understand with these 10 runs is how does varying the extraction window in the ppm dimension and varying the extraction window in the retention time dimension, how does that affect my results? So here I have the 10 ppm, 10 RT. So double click on that, and then that will start loading.
Brendan, can I ask a question? Yeah. So all of your Skyline files have the same name. Is that problematic? I mean,
they're all in separate directories. I mean, if you wanted to, you could modify the script to save to a new name.
Okay.
So, like I didn't, that wasn't a priority for me, but it would be a very minor edit to the Skyline. Like, so yeah, here we could go to this Skyline bat file, and basically this is the place where we take the template and save it. It would be a one-line edit to change it so that we saved it to a new file name. Okay, so yeah, so it hasn't been a problem, too much of a problem for me. Yeah, sometimes like, oh, yeah. But anyway, so I've been putting them in a separate folder. So here's my Skyline document open. I'm going to sort of place these windows here. In this case, I'm still in log scale from yesterday, but you can see here are my six runs. You can see I'm in a document with 500,000 transitions and 88,000 peptides. How many peptides am I targeting? Am I targeting 88,000 peptides? What? Where are you getting 92,000? Oh, those are the precursors. Am I targeting 92,000 precursors? well, I guess kind of a trick question. It's in the targets, but actually that's twice as much as what I'm really trying to analyze because I've got decoys. So if you put the cursor down here, now, ooh, that's kind of cute. Then you can see the first number is 46,000. So 46,000 precursors above the decoys. But yeah, I always like to take a look at these IRT injected peptides, because what properties are they supposed to have in these summary windows? What do we expect in these summary windows? Yeah, they should be constant in both things, right? So I'm going to actually get out of log scale here. We were looking at that yesterday to see how one of them was changing by 100-fold in the Spiogenes data. So yeah, turn off log scale. Okay, so maybe you see that there may be some signal decline of one of these peptides, but or actually over all of them, they kind of decline a little bit over the runs, but they are pretty stable. But that gives you, these are standards, right? These are injected internal standards that give you some insight into sort of global impacts on your file. And then this view, I can go view arrange graphs tiled, and now I can get a chromatogram view, and I should see really pretty nice peaks for all of my IRT peaks. And there's all kinds of and I can also go view mass errors histogram. So we could do a histogram of the mass errors, and we could say, yeah, they're pretty well centered on 0. With a standard deviation. So this should give me this already should give me some information about, like, well, was the 10 ppm extraction window appropriate? Or the 10 ppm tolerance, so it's 20 ppms of extraction. And I would say, yeah, if instead I was seeing a much broader distribution that looked cut off, then I might go, ooh, I think I'm using too tight an extraction window. And actually, one of my goals this summer is to create similar histogram views for the retention times and actually also for the peak areas, so that you can get some insight into your CVs. So we're going to be adding even more useful plots. But yeah, you now have this Skyline document sitting here. No extra work. It's just a byproduct of your script. And if you didn't like it, you thought it was too big, you could have your script delete it. But it's a very useful artifact, so I would recommend keeping it around. Okay, so yeah, so back to our command line results. Okay, so that's one thing that's in each one of these folders. I have one for each run, and I could. So I'm gonna go ahead. And I'm going to open another one. So I will go File, Open. You may not have this. I'm just going to do this. Let's go open a too narrow ppm one. Do we have one? ppm 5. Yeah. So let's open ppm 5, or I'll open ppm 5 since many people may not have it. But let's go back. I just committed a cardinal error. I was told last night, don't switch between a whole lot of things. So let's keep looking at this this one folder that we have. So we have the document. We have 2 reports. I actually rarely open these reports directly because they can get kind of big. The peak areas one's not too big. It's 4 or 5 meg. Does anybody want to open these in Excel? You can definitely open them in Excel and look at them. But with this kind of report, especially with the size of data we're talking, it's much more useful to import it into R and digest it a little bit. And I guess we'll go look at that in RStudio in a second. But so now my R scripts. So this is all, before the R scripts run, Skyline has created all of this, right? We've got 2 reports, Skyline file, SCID file. and then I run my R scripts, and I get this log, plot, and supplementary. And I actually mostly focus on log and plot. These are created by the LFQ bench script that we installed on the first SkyJam. And then I've added a plot, which is this peak areas summary plot. So yeah, let's go into the plots. So all of this, the peak areas plot is the one that I create with my own R script. I'm going to take you to that R script in a second. Let's just open that plot because it comes up really quick. So this is this plot where it shows like how many things I found in each run, and this is only for human. So this is a 3-cell lysate, and so while 16.8 thousand human proteins is actually relatively small for what we think is possible to detect, or this is precursors even. The fact that it's 3 organisms is an incredibly complex mixture, and that's what was in the library. The library didn't contain a whole lot more. So this is what we're seeing, but we're seeing really good stability. We see, this, 16.2 are in all runs and 17.2 are our total. So we're not getting a lot of explosion. We're actually getting incredibly, we would see a very filled out data matrix for these proteins, and then, or these peptides, and then now we can go and look at, and that's also represented in this histogram where almost everything is in 6, and we see some trailing. We don't really see very much at 1. So there's no applying global Q values, and all the tricks that we were hearing about yesterday just really don't apply to a data set this size because there's no problem with false discovery rate accumulation. And then now we can get some assessment from these last 4 plots of what the CVs of this data look like, and they look pretty good. We're getting almost 90% above 20 in all runs. So that's pretty good, I think. And then you can get a 2D plot and get some sense that, yeah, most of the things that have poor CVs are less intense. Once we get up to over 1,000, we have very few things that don't have a 20% CV. So that all looks good and should make us feel like the data is pretty good quality. And then there's a bunch of, I'm going to just open up again the proteins plot. So this is the test in that manuscript. If you go read that manuscript, you'll see plenty of these plots. You just generated them, and in fact, you've generated them. If you run that script, you'll generate them for 10 different trials. And the goal was to have yeast should be 2-fold change. Humans should not be changing at all. That's why we get to run that other script on them. And then E. coli should be 4-fold change. And basically, these lines should line up. And in fact, as we get down to lower intensity values, we would expect this to curve away from the line a little bit. That's just what happens because we're going below the lower limit of quantification for these things, and they just are not. This relationship is only guaranteed as long as they're linear. They're in the linear range, right? So twofold. Yeah. So anyway, okay. Okay, so let's go. Yeah,
Ben, I just have a question.
Yeah.
So I would also like to see, particularly those points. Let's say these E. coli ones. They also move up there in the orange area. So they are a bit scattered around, where the majority is where you actually expect them. So I would like to see what's going on with these kind of data points. Are these just single peptide observations or so? So what's going on with this? So how could I go in there and check these out?
You'd have to like write something that found those that extracted those out of your report. I mean, so that's the sort of the constant battle that we're fighting with Skyline is what I was trying to show you yesterday, the ability to get to things like this. And now and that's great. That's exactly what I think you should be doing all the time is like like too frequently we go like, oh, okay, that looks good enough, and we go right by. But yeah, it's like, oh, wait, I have one more question. And the problem is that if what we have is a PDF and an Excel spreadsheet, getting to the answer, like your question's a great question, getting to the answer is going to take you effort, right? It's going to take you and quite a bit of effort. And so that limits your next question, right? Now you got the answer to that question. Oh, now I have a new question. And so in a day, if it takes you very long to figure out, to ask questions and get them answered, you're going to run out of energy. You're going to stop asking questions, and you're going to eventually, the quality of your results is going to suffer. And that's exactly what I'm trying to get across with, Skyline. I said years ago, oh, the bottleneck here is human understanding. And so you want to derive human understanding of what you see. And so Skyline's entire goal is to get you there quicker. And yeah, there are times where you can't get there quicker, and I'm always looking for ways that we can improve Skyline to get you there quicker. And it would be fantastic if this were a plot in Skyline and you could just click on these points and it would pop you to that thing, and then you could look at the chromatograms, or you could look at, now I'm in the protein. Let me see what other peptides are in this protein that, and stuff like that. So that's not the case yet. So once you drop into this R mode, you're back to the mode of like, okay, I've got a PDF. Oh, what is that? Okay, I've got to go figure out. Now I have to write a script to figure out what that is. And so the investigative cycle will slow down once you get in here, once you get into this mode. But still incredibly powerful. Lots of things you can do. Okay, so everybody feel like they have a basic understanding of how this script is working and what it's producing, and we'll go troubleshoot some things. Does anybody have any questions about the basics of, there is this template file at the top, this thing that we saved into a folder. Then we imported data into that created that SCID file. Then we built a model and repicked all the peaks, and then we exported 2 reports, and then we used R to generate information about those reports. Oh, and then the last thing is, in this log folder, there's this metrics.txt, and this is LFQbench again. And if you open up metrics.txt in one of these log folders, again, it's similar to the Sky file, it's always going to be metrics.txt. It's going to have, but at the top of it, there is a number which is identification statistics. And you can see that we got 41,621, which is very close to the number reported in the paper. So all this centroided MZXML with thresholding and everything doesn't seem to have had a big negative impact on our number of identifications. And it doesn't look like it's had a big, terrible impact on our quantification either, because the quantification looks pretty similar. So, but this number then, what I did, so I leave this for you as an exercise at home. We're going to just try to get you all through having run all these things. What I did is I went into every one of my 10 folders, grabbed this number, and put it in an Excel spreadsheet. And you could have your R scripts do the, add to something, but I just went to these files, copied this number, and put it in an Excel spreadsheet, and that was my extraction comparison spreadsheet. It's a really simple spreadsheet. So you can see here I have ppm, and I went over my 5 to 40. This is the trial I did. And then I have time in minutes, and I go 4 to 30. And then I went and filled in all the identified counts that I got out of those metrics.txt. And then I plotted them. And so what can we now say about what would be the optimal number of ppm for this data set? Our tolerance, our extraction tolerance. 10. And does anybody wonder if maybe 15 would be better? right? Because I don't have a point in the middle, right? It's like this is graphing like this, and you know, this point might actually be higher. We're just drawing between these 2 points. But I actually did it, and it just falls right on this line. So yes, 10 is truly the optimal width for this data set, which you know, again, correlates perfectly to what I found when I did this for the paper. And then what's our optimal retention time window? 30. Yeah, it actually keeps going up. And if we went in and looked at the logs, you'll see that as we widen the retention time window, retention time becomes a more powerful score in those models. So the power of retention time, as you widen the window, the decoys start falling more spread away from the target, and that makes retention time a more powerful score. So you get a little bit of benefit, but I would say that probably, you know, I settled on 10 for the paper. You know, it's not totally clear to me that I'm definitely I might be increasing my false discovery rate here, maybe not. So I don't know like I'm getting more identifications, but am I getting more identifications at what rate am I adding false discoveries? So if I add 50, 100 new identifications, well, if 30 of them are false discoveries, that's not a good trade-off. And then actually, if you look at the size of the SCID files and you know, I can show you just here's the time they all took to run. So a 30 retention time window takes me 40 sets, so it takes me another 50% longer to run than my other analysis. And so I'd say, yeah, I don't think it's really worth it to make it wider. So the 10-10 that everybody's run is what I would recommend as the optimal based on that analysis. And now, hopefully, you all feel like you could run something like that. Let's take the last 10 minutes to look at this R script. So do people, okay, so if you don't have RStudio up, go ahead and bring RStudio up. Run RStudio. And so when I started, we did all of this installation just to get ready to run the LFQ bench script, you know, to run this. I'm going to go ahead and open now. So there's this generate report is what runs LFQ bench. And so then I have to set up parameters, point to the files and everything. And this is just all setting up to run this complicated script that generates the metrics.txt and the plots with the 3 colors. And that's a big, you know, that's the kind of script where you have to find somebody to write that script for you, and you have to look for a script, you know. So MS Stats is that way too. You're looking for somebody else's script. But so what I'd prefer to focus on is to open the script in scripts. So this is my peak areas human.report. So I created my own report. I have this detection.r. It's a pretty extensive script at this point. It's something I created while working with Ben's pan-human data, but it started really simple. And it provides a framework that you could use too. And so you could grab this script and rip out its guts, and then you could keep this stuff where these are the command line. This is like helping you to get command line args, and then there's, is it a command or is it not a command? And so you can see, say, is it a command? Then we get the report name, the path to the report off the command line. Otherwise, we're just going to point to the report inside here, right? So this is the path to the peak area CVs that everybody has, right? Everybody has this CSV file? Right, so that means that you, if you wanted to run this again, could just click source. So right here, click source, and you'll see it says, I'm reading the CSV file. Okay, I'm generating a PDF. Here's some statistics. and now it's telling it, and then it's done, right? So that just ran my R script, and it ran it with a fixed path. And if I wanted to say, oh, actually, I want to do the 20 ppm, I want to do the 20 ppm one, I can change that path to point to whatever CSV I want. Here's where I construct the path for the PDF file. And then this cat method, that's what's using cat is what puts output to here. So that's how so you can see it says reading, report path, and then it says generating PDF path. So this is really, so how many people have some experience with R? Okay, wow, great. So yeah, so this is pretty simple stuff in R, and then eventually you get to this, you create a data frame, right? You go read.csv, and now you read the report that Skyline output for you. And that's sort of the takeoff point after that. So you could go ahead and grab all of this preamble and use it on anything where you've exported a report from Skyline, right? So you can start, and you don't even have to run it from the command line. You would start out running it from here by clicking source, or you can do these step by step. You can see here I have head, right? So I'm heading the peaks table. So let's see so go ahead and uncomment that head and select it. And then you could click run or control enter to run. And there's what's in the peaks table. So this is what came out of my report. You can see I have the peptide, the modified sequence, the precursor charge, and then I go into total area and Q value. And I repeat total area Q value 6 times. And then after that, you can see that I've started to append columns to this data frame in my script. So when you're in your command line development phase, you might not do the R script part. You might just run the command line, get your report, and then you go back into RStudio, and you've got this report path, and maybe you're going to output to a PDF, and then you start working. You import read.csv your report. And now you got a data frame, and you can work with that. And then for me, down at the bottom is where I put all the, so we say, okay, we're going to do a PDF here, and we give it the PDF path and the width of the plots, and then we do, I think at this point I can just select that line. So this is plotting. Plot runs bar and line, so I've created a function that does one of those plots. I'm going to select it. So this is, if you didn't catch that, you just get to the bottom. All the between the read.csv and the bottom are functions to do the plotting and just data massaging, right? And then at the bottom, I say, okay, here's my PDF. Here's my plot, now I have my plots. But when I'm in RStudio, I think I can just go I can select a line here and go control enter, and then I get the plot in this view, right? So that's incredibly useful when you're creating these plots. And you got a bug in the plot and it doesn't look right. Well, now I can, I have these various plot functions up here, plot CVs. Probably the simplest one is plot CVs by intensity. It's right here. And here's where I call plot CVs by intensity. So I can select this line and control enter. And there's my plot CVs by intensity in RStudio. And I could go, I don't like that title. I want it to say, I don't know, whatever I want it to say. I can go up in here and say, and now I I have to select this function and say Control-Enter to redefine it. And I can go back and that's it for a little introduction to RStudio. I think you're going to do more with RStudio today. Hopefully that wraps us up for command lines. And tomorrow, anybody who's been coming in the morning and would like to actually try to get through the full 10 analysis, or you had an error, like catch me during breaks, and we'll work that out and try to get everybody running the full analysis. But not till tonight, yeah. It's what you're going to start, right? So we have all day, we have breaks. You're going to get to do this. Yeah, you'll get to do it tonight.